So let's take a look at finding the average value of functions. So the formula for average value is 1 over b minus a times the integral from a to b of f of x dx. So obviously f of x is just your given function, and we're taking the integral of that from a to b, and a to b will be your given x values. So if you have from like the x values of 2 to 3, then your a value will be 2 and your b will be 3. For all of these problems, we have to find the average value of the function over the given interval. So starting off with number 1, we have to find the average value of y equals 4 minus x squared over the given interval from 0 to 3. So if I were to write the formula for the average value once again, it's 1 over b minus a times the integral from a to b of f of x dx. So if we were to write the average value of this function, we would write 1 over b minus a. So this is our a value, 0, and our b value is 3. So we're going 1 over 3 minus 0 times the integral. We're going from 0 to 3. Those are our x bounds. Times the integral from 0 to 3 of f of x, which is 4 minus x squared dx. So just simplifying a little further, 3 minus 0 is just 3, so we have 1 over 3 times the integral from 0 to 3 of 4 minus x squared dx. So now to evaluate the integral, we have 1/3 times the integral of 4 is just 4x, and the integral of x squared, you can just use the power rule, is x cubed over 3. So we have 4x minus x cubed over 3. And we're going from the integral, or from the interval, from 0 to 3. Then I'll just keep 1/3 outside. When I plug in 3 for x, we'll get 4 times 3, which is 12, minus 3 cubed over 3. 3 cubed is 27, and 27 divided by 3 is 9. And then when I plug in 0 for x, I'll get 0 times 4, which is 0, minus 0 cubed over 3, which is still 0. So then to simplify, we get 1/3 times 12 minus 9, which is 3. 3 minus 0 is 0, so we just get 3. And that gives us the value, or the average value, of 1. So now for number 2, we have to find the average value of f of x equals 1 over the square root of x from the given interval from 4 to 9. So once again, I can plug all my numbers into the formula. So we get 1 over b minus a, so b is 9 and a is 4, so we get 9 minus 4. Those are our x bounds. Times the integral, we're going from 4 to 9, times the integral of f of x, which is just 1 over the square root of x. And I'll actually rewrite 1 over square root of x as x to the negative 1/2 power dx, because now what I can do is use the power rule. So if I were to simplify the fraction on the outside, I would just get 1 over 5 times the integral of x to the negative 1/2 dx. And then to simplify further, we can use the power rule to integrate. So we get 1/5 times x to the 1/2 divided by 1/2, or multiplied by 2. So then I'll bring the 2 over on top, so we get 2/5 x to the 1/2 power, and we're going from 4 to 9. I'll keep the 2/5 outside of the bracket, So then I can just simplify x to the 1/2 and plug in 9 and 4. So when I plug in 9, I get 9 to the 1/2 power, or the square root of 9, which is 3, minus when I plug in 4, 4 to the 1/2, or the square root of 4 is 2. So then we get 2/5 times 1, and so our average value is 2/5. So after we've found the average value, let's say the problem asks us to now find all values of x in which the interval for which the function equals its average value. So this is pretty simple. All you have to do is take the average value and set it equal to the original equation. So we're going to say that 2/5 is going to be equal to 1 over the square root of x. So we're just trying to find for which x values does it equal 2/5, which is our average value. So if I were to simplify this, I would just cross multiply. So cross multiply those values. I get 2 times the square root of x equals 5 times 1, which is 5. So then if I divide the 2, I get the square root of x equals 5/2. And then to get rid of the square root, I have to square it. So then x equals 5/2, the entire fraction squared. So then x is going to be equal to 25 over 4.